Okay, let's get started. For students on that side, if you feel it's too bright, you can put the curtain down, like what they have done. Well, you may feel better that way. And first of all, welcome to this course, 4423. And I'm not sure if you guys know, this is actually the second time we're offering this course. So we're still developing a lot of stuff, and I will introduce it later. And what makes me really happy is this is a nice place. It's actually my first time being here. I guess this is one of the best classroom, has the harbor view. So enjoy it. Okay, my name is Xiaoyong Wei, and so I'm actually a visiting professor here in the Department of Computing. So before that, I actually have been visiting the Tampere University as a professor as well. And I am adjunct professor at the Pongsen Lab, Shenzhen. And the place I hold the professorship is actually the Sichuan University, and where I have been acting as a department head as well. And I have done my postdoctoral fellowship in UC Berkeley, and I actually graduated from here, from City University of Hong Kong, for my PhD degree. And I'm proud to be one of the founding members of Varial. It's a group for multimedia computing, and I am now a senior member of Attribute. Okay, actually, there are a lot of stuff, and I guess probably not interested. But here is the QR code. If you are interested, you can scan it for my homepage. Actually, I will put these slides on Blackboard later, so you will have this information. Don't worry about it. So our work has been reported widely by media. This is the media coverage by another famous media like the BBC, Telegram, and CCTV as well. And in case you're interested, and you can search over the internet, find our previous work. Okay, so doesn't work well, this microphone. So my office hour is every Wednesday before the lectures, and you will see 13:30 to 15:30, just before this lecture every Wednesday in the afternoon. So you can find me there in my office. And also appointments are possible at other time slots. Just send me email, or you can call me with the number showing there. So the language is used in this classroom, and it's mainly in English. I consider myself a professional English speaker. And at the same time, I am a Mandarin. I consider myself a native Mandarin speaker, even not people don't think so. But I speak Cantonese as well, and spending all my life pretend to be a native speaker. Yeah, trying hard, but I know the basic stuff, and it's okay. If you have questions, you want to speak in Cantonese, that totally will be fine in this classroom. We have 3 teaching assistants for this course. Shilu is one, who's sitting here, Zhang Shilu, email showing there. And we have the other 2 TA as well, but they are getting infected by the COVID. They can't be here today, so they will join us later. I guess they're probably online. So their name, Chang Meng Zhen and Bo Liu, the other 2 students, teaching assistants here. And I will introduce them later when they will be here. So, okay, and that's pretty much about our background. And let's get started to the course, computer vision. So what is computer vision? Do you have some idea about it? Do you know what? Okay. Okay. Yeah, yeah, that's great. Yeah, okay, good. He's mentioning it's about the human behavior. So that's right, that's correct. And other answers there you would like to share?
Computer is able to see like a human.
Okay, great. Just it's mentioning that we're actually teaching the computers to understand the world through the vision, the computer vision, rather than the human vision, right? You actually trying to make the computer behave like a human, right? To understand the world. Okay. I'm not inviting any more answers there because actually, if you're asking me this question 10 years ago, I probably will give you a definition and answer there. But today, I'm not going to do it because I have no idea about it. So the reason is you will see very soon this computer vision is under developing. Something happened recently, make as explosive development on the computer vision. So I guess you heard a lot about deep learning, right? Deep learning stuff makes really popular. So that's the reason, probably one of the reasons you're here, because we have a survey online asking why you're picking this course. If you haven't done it, you can do it now or later on the Blackboard. So I do see some students take that. This is a very hot topic. That's the reason I'm being here, right? So and really, I have no idea what computer vision is because it's under development. If it's about 10 years ago, I can give you a definition, but not today. However, computer vision is everywhere, right? Because everything about the most straightforward way we are related to the computer vision is we're using the cell phone. The cell phone has a camera on it. I guess everybody has a cell phone there, then you have a camera on it as well. So nearly everyone in this world, they're using the camera every day. They're taking pictures, they take videos there as well. So this is something tightly related to computer vision. So we are, which means we are in the history of development of the computer vision right now. You are part of the history. So probably you will be the one defining what computer vision is. So, but as ordinary people, because we just started, how can we get more understanding, grasp more understanding about computer vision? The way I'm doing it is just play with it. So let's give you some examples today. Note them using the examples, some examples there, because there are actually a lot of them there. I can't show them today here. Let me just show some example. The first one is I'm showing here. It's handwriting recognition. For example, you can write something and it will be recognized here. Let me refresh that. Like when you're right, you see here, it's a 7, recognized. And let me write another. It's a 2, right? So 0, let me do it in different way, 0 as well. It's 0 as well. No matter what way you're writing it, it's always give you one answer. Works pretty well, right? But this is not some novel stuff. I guess everyone has already tried it because you have it on cell phone. You can do the handwriting there, right? Your writing will be recognized as a words, as a character. And this is one, maybe that it connects us with the computer vision. Let me show you another example here. Another example is, okay, not this one, this one. So you see, I got some pictures here, and when I click on it, and the system will actually recognize what inside that picture, you will see here team sports, ball game, multi-sport events, baseball sports, or something like that. It makes a lot of sense, and athletes as well. So let me give you another example. Here, this image is too large. Actually, you can, this is a very good demonstration here. You could see here player, which makes some sense. They are actually audience here, but because they're in a uniform, they probably has been recognized as players as well. And also other stuff is we actually got 2 person here. You could see there are something about them. Person landmark, and you can see they have been recognized. Let me change it to other stuff like this one. And I'll see, okay, you see here, pet dog, mammal, toy dog, something like that. And let me put the recognition, and it doesn't recognize that well. I'm actually looking for one image where I can have some expressions on it about person. It doesn't work well. Let me try this one. Probably they will have it. No, okay. It's kind of embarrassing. It doesn't recognize very well. Actually, you could see it. Oh, this one worked well. You can see here, the person 1 here, he's showing an expression of joy. Yeah, it has been recognized here, and she has the health wear as well, which has been recognized. The other 2 girls, because they haven't been recognized with emotions there. Okay, you could see here, this is actually one example. He just mentioned computers are more or less be able to recognize the content and the image as a human being. This is one thing, one example. And feel free to try it later. And actually, if you, there's one image there. There are actually several images there. You can see the text information, which are here, can be extracted and recognized from the image as well. So it's not necessarily about handwriting stuff. So, and this is another example about computer vision. And this is another one. And there are some faces there, and the other 2, do you recognize them? No, right? You don't recognize them. Me neither. Because the reason is those images actually generated by the computers. They're not real people, but it looks so real, right? It's kind of give you some feeling that you know those guys. And actually, it's from here. Here is a website called This Person Does Not Exist. So every time you refresh the link, it gives you one face, and it's generated by the computer, and it doesn't exist in this world. So something like that. It looks like someone you're familiar with, but you just can't name it, right? So it's the reason is they actually generated by the computer. The way the computers generate it is they're using a lot of samples to learn. That's the reason when you look at them, it's like someone you're familiar with, because they're actually learn something from those existing pictures. And because you got some understanding on those existing pictures, and those computer will learn that fact as well. So that's the reason when you look at them, it's look alike someone you're familiar with. So this is another stuff that is we can actually use the computer to generate the images. And this one is about the faces. Actually, it's raised a lot of concerns recently because those faces are fake, but someone are using it for some illegal purpose there. It's raised a lot of concerns there. So at the same time, people are developing a technology to detect if this is a real face or not. So anyway, this is also computer vision to generate the image or to detect if it's an image generated by the computer. So, and actually there are a lot of websites about them, just name two. And let me give you more example. How about this? This one is kind of different from what I have shown previously, because in the previous image, it's just showing some ordinary persons there. But this one looks like the ethnic minorities there, right? They got a lot of makeups on face. So, and this one as well, they are look not so real, but beautiful at the same time. It's kind of artistic, right? So those are actually generated by the computers as well. And not only for faces, we're able to generate the cities and also the inner design stuff, interior design, and also see these two buildings. They're so fancy. And the one on the left, it looks like the one outside the window, right? Yeah, with the very similar patterns there. So, but what is different from the faces I just shown? This is a very popular topic recently called stable diffusion. They are using let me show you the websites. And okay, this is a website where you can use it, the stable diffusion model, to generate an image with some descriptions there. And you can we can try it, like a lady, sorry, a lady working on a laptop in a classroom. So it takes a while to generate that image, and you will see it very soon. And yeah, a lady working on a laptop in a classroom, something like that. Even not that so good, but it's different from here. What different from here is this one gives you one image randomly, and however, the stable diffusion generated image with your description, meaning that you can actually control what to generate there. So that's the reason makes it really popular. And also you can actually change it like with different style, like making it a watercolor. Yeah, that's it. So you can see it. Yeah. And actually, there are a lot of descriptions you can try. And let me try some of them here. And the others, you can try other sentences by yourself, because I'm going to share these slides with you on the blackboard. Okay. It looks so fancy, right? Yeah. Anyway, you can modify the description by yourself. This model is really popular, and actually there are a lot of artists, they're so worried about that because it's like their computer vision is going to take their jobs here, because those pictures are so good. And you know, it's not actually that novel stuff. This is a news 4 years ago. And this is a picture generated by the computer, but sold for real money for something like 400,000 there. So anyway, it's create a lot of opportunities there. This is about image generation, and image generation with the guidance of the text description, which I have just showed. And okay, other thing you might be familiar with is the Tesla. It's really popular, right? And if you go on the street, you see a lot of Tesla models there on the street. But Tesla make a lot of, they actually introduce a lot of stuff to public, right? Before Tesla, I think most people, they don't understand what is the pedestrian detection, lane detection, or something like that, right? What Tesla is doing is they're using a camera. This is one thing they're proud of. And as another option for cameras, they can actually use a lot of sensors here, right? But they don't use the sensors. They are proud of, they are building their models based on pure computer vision, you know, and which make the pedestrian detection, meaning that detection of the pedestrian, and the car detection, lane detection there. Let me show you another image there. You could see here, because when you're driving, what appear in front of the vehicle is quite important. So you're going to detect the cars and the lanes there as well. So you know, the computer know actually how to control the vehicle. It's you're putting them into self-driving mode. So which make at the same time introduce a new topic. We call it object detection, because those are all objects, right? The cars, the lanes, and other stuff, the skies as well. So that's object detection. And you can use object detection to detect a lot of stuff, like the animals, like the persons, and anything a human being can detect. So this is another research area, one of the main research area about computer vision. And also, semantic segmentation is trying to segment. You could see it as a more detailed detection, because it tells you the area about each of the objects in the image, and that's a segmentation. And also, beside that, another very popular topic is style transfer. People has done that for years, and actually you could see the Stable Diffusion, beside image generation, they can do style transfer as well. But there is another bunch of people that are doing this style transfer specifically. They may not use the diffusion model. Anyway, as I mentioned, I'm not trying to be systematic and comprehensive as well. So I'm just picking some of the examples to show, and most of them are really popular, or they have already been done in computer vision community for years. So, and also those are in probably in the factory construction sites. You can use the computer vision to do the surveillance analysis on it, so you know what's going on sites. And also a lot of stuff related to the safety issues there, like whether the worker is with helmets there, and that's quite important. You can use that detection analysis to help the management. Also, those are some PCB boards, and on PCB boards, we can use computer vision to measure if every component is up to standard, like here is a circle. Is it round enough or something like that? You can use computer vision to detect it, to improve the quality of the manufacturing. So this is another application. And okay, as I mentioned, I'm not going to be comprehensive. I'm just trying to give you some impression about the computer vision, and most of them are just applications there. But up to here, if you are asked what is computer vision, do you think you yourself have a better understanding about it? Maybe based on your previous understanding, you know some new stuff. You're exploring your understanding, right? So actually, that's the way we're going to do in this course. We're going to explore our understanding, extend our understanding on computer vision together by exploring it, by playing with it. So however, it will help because you know that actually have been working on computer vision for something like 20 years. So I learned a lot from this process of development. So it will help if we look back to see what happened and compare it back to what we have today. I guess this is another way to grab the understanding, because previously I just showed a lot of current applications of them. So if you look back, like in 1957, this is a quite important year. This image is actually the first digital image in this world. It's about a baby. That's actually the infant son of the engineer, Russell. He's leading the development of the digital images there, initiated by NIST, not NASA, sorry. So this is the first digital image. It means a lot, even it's the quality is not so good from Kevin standard. However, it's the first one. It means a lot. The reason is once you make things digitalized, the computer can analyze it, can process it. Otherwise, before you have these digital images, everything it's just printed on paper. Computer can barely do something on it. But when it's digitalized, they're becoming numbers, right? Because most of the students are coming from the computing background. I guess you understand this very well. So you can program it to help the computer to process it, to understand it once it's digitalized. So, so after that, people are working on digital images, and like at the early 1960s, a lot of researchers they thought computer vision is a simple task, because you know at that time people developed computers and use a computer to process the text information, like what you type in into the computer, the words, the characters, right? Those are very simple stuff. People build the databases on it, and they have done a lot of analysis on that, processing as well. So at the same time, they thought the vision stuff is just the visual input. It's just another kind of input to the computer. In case you, the scientists or researchers has already processed the text information and the signals information as well, very well. So they think the visual information just another type. So it's might be an easy task. Looking back, something like right now, it's 70 years ago, right? But we are still struggling on this easy task, right? So that is to say our understanding today may not correct, right? Even the deep learning is really popular. A lot of people believe that deep learning is going to solve the computer vision problem, but yes or no, I don't know, right? So that's the reason we're learning it, we'll keep working on it. Okay, I forgot to mention, this is one of the example taught in computer vision course that it's one of the first tasks people initiated for computer vision. This is a professor in MIT, Marvin, who asked his undergraduate students as a summer assignment to associate the computer with the camera. This is actually trying to recognize what appears in a camera. And here is a model he has given, like to recognize a car, and you actually got another properties for car. There's a name, there are superclass as a vehicle, and number of wheels, something like that. So at that time, people think if we can build a model for some of the objects like the car, this is a very simple model. And by filling out the properties of that model, and we can understand what appears in the camera. So this is a way people were thinking about how to solve the computer vision problem, but it turns out it's not that easy, right? So as we know today, but people did spend a lot of efforts on it. Like this is well known, still they're still using today. Like to model a human, you can use the matchman model. There are some joints about the body, and once you can detect, like the head, like the shoulder, and the leg there, and you can detect the person there, right? So you can recognize the parts of the human, and at the same time, you recognize the person. So that's the idea, very simple model there. So after that, people spending effort, because it turns out the model one is easy because the human being has already the understanding about different objects. We can easily build a lot of models for a person, right? But the problem is the computer can't easily recognize different parts, right? Like for the face, it's such a headache. People working on the facial recognition for a really long time, and so which also make facial recognition is always at the center of the computer vision. One of the challenges people trying to take. So, and at the same time, you could see here the semantic segmentation as well. At the same time, already been studied by researchers there. And also later when we have the depth camera, we could not only capture the colors of the objects, at the same time, we could have the depths using depth camera. If you have played with the Microsoft game with the Kinect has the depth camera on it, and also have the so-called RGB cameras there. Like most of the time we're using on a laptop, and when you are using for civilians, most of them are actually RGB camera. But depth camera tells you the distance of the object to the camera. So we can combine such information for a better understanding. And this is one we can use the depth camera with the RGB camera to reconstruct the 3D models of the objects. And this is another very popular topic that day. You could see that's about 20 years ago, right? But right now, people are still working on it. So it's not a solved problem. And actually, but at the same time, people realize to understanding the objects in a camera, it's not an easy job. But because at the same time, to improve the quality for better use, it's another challenge as well. So people are spending a lot of efforts on the image precision stuff, which we will teach later in this course. Like here is image stitching, because when you're using the camera to take image about scene, like because the camera can only take a part of it, a portion of it. So you have to take several photos to cover all the stuff in the scene, right? So you have to combine them together. It's not an easy job because when you're taking it, it's not perfectly overlapped. So you have to figure out a way to how to merge them to look like the same image by merging several images there. So it's called image stitching. And also, when you're taking the image, if you play photography, you know that explosion and a lot of parameters related is quite important, which results different images there. So at that time, how to use that to generate a better image has been studied as well. And people are still working on it nowadays as well. And also how to blend images there, like showing in the last row there. It's also another very popular topics that time. So, okay, just trying to also show some example. But at that time, that's 20 years ago, you could see there, because I have introduced the basic assumption is human being can build a very simple model or description about the objects. And the idea is if we can recognize the property of that objects, we could rebuild that model in a computer, right? So which puts the recognition at the core of computer vision. So that's the reason people are spending efforts continuously on that research topic of recognition. And this one, facial recognition, is known one of the most popular one. So, and also the handwritten digits as well. However, at that time, due to the limitation of computational power, when we are teaching the computer to learn such stuff, we can only teach them on a small size of examples. And at the same time, we can only collect a small amount of images there, because you see there it's 20 years ago, and internet, and it's not that popular like nowadays. 20 years ago, when you're visit some of the websites, it's really slow. People don't put too much images on websites because it's slow. It doesn't give the user a good experience of browsing there. So anyway, at that time, we can only work on small samples like what's shown here. This actually the two of the most popular data sets at that time. And this is about all examples they have. It turns out when you are, we call it train a model, when you train the computer to recognize something, the training is based on a small size images there, meaning that the final result, the final experience or knowledge of the computer is based on those small samples. And there are probably a lot of other situations that haven't been covered by those small samples there at the same time. So it's the result is it's not to generalize that knowledge to other conditions. Like I can take pictures in this classroom and build knowledge on that to teach the computer to understand. However, when I change to another classroom, because the illumination changed and the objects changed as well, those understanding cannot be applied to that situation, the new environment. So that can't be adapted. So because they're just too small. So later, here comes a very, this is considered one of the milestone of the recognition. Actually, this probably the main reason the deep learning has been initiated. The study of deep learning has been initiated. This is a data set. You could see it covers 1,000 object classes, and there is over millions of images in it. So it's a really large data set. People spending efforts to collect that. Once you have those more training examples, you can train your models to have a better understanding, which can be adapted into different environments. So that's the idea. So once we have that, it gives the chance to deep learning. Deep learning is, you will know later, deep learning is also not a novel stuff. Deep learning is about neural networks. People have studied neural networks many years ago. They started that. It's not recently they developed it. So, but anyway, the neural networks. This is a one well-known one called AlexNet. They build on the data sets I have shown in previous slides, and with outstanding performance on the data sets. And it actually outperformed a lot of traditional models there at the same time. So you could see this development. This is about the same time the ImageNet has been developed. And later, in 2 years, this AlexNet outperformed all of the previous models, make people to see the opportunity of using the neural networks, more specifically deep learning, to build the models. And later you could see the developments and the performance just go up. And so that's the reason deep learning initiated a lot of stuff there. Okay, so this is not that complete introduction about history of computer vision. But the core is, you could see those technology has all the stuff we have today. We already had it previously, but once we got some new sources, we got more understanding of it, and we can keep developing that. So the understanding we have today may not valid in the future. That's one reason I'm not going to define what computer vision is, because I don't dare to, based on my experience, right? But we can feel it, we can play with it when you're asked the question. And as a little conclusion here, we have introduced a lot of examples there and application there as well. There are some keywords you could see: the recognition, classification, segmentation, and so on and so forth, blah, blah, blah. And those are keywords, and we're going to introduce them in this course. This some of the core concepts we're going to introduce, and among others, and other keywords I haven't mentioned today, and because it's not easy to be comprehensive as I introduce. Okay, so the way we're learning that, my way of learning that is learn by playing with it. So we can playing with it. Do we have to take a break? Do you think we can just do this all through, or we can take a break for something like 5 minutes? Okay, so yeah, let's take a break for 5 minutes, come back at 4:25, okay? Okay, let's just continue. I appreciate some students ask the questions. The first one is about Colab, because we mentioned in the email that we're going to use Colab there. However, at the same time, we understand there probably some of the job might be computational intensive. Colab is not a good option in that case. So the way work it out is we're going to use Colab for tutorials. Because in tutorial, we're going to introduce some basic concepts there. The point is you use it there. So it's not going to be computational intensive in that case. So I guess based on our experience last year, Colab worked very well. And but at the same time, if, for example, there's an assignment there, and you probably design a more complicated model there, which need another computational power, you might have to seek some GPU for it. For example, in the lab, we're going to have the tutorials where you have a GPU on each machine where you can use. So that's, and if you have other resources, you're welcome to use as well. We don't actually have requirements on it, on which platform you're using, but just let us know in case that sometime our TAs have to verify your code on their machines there. But most of the time, I guess you're using something like PyTorch, like the Conda there. Those are quite popular stuff, and it's okay. Okay, let's talk about that later. And about the microphone, I just figured out that I have to hold it this way to make it better. So, okay, let's just continue our introduction. As I mentioned, we're going to learn the computer vision by playing with it. This is my experience for years. Actually, I started teaching the computer vision 10 years ago. So I have done a lot in the courses, and I figured out this is the best way. So let me give you an example of it. This is what we have done 10 years ago. It's called in-class social network mining, where I'm going to show that we can practice what we've been teaching here in the classroom at the same time with our own data. So that will be more interesting. Actually, 10 years ago, we're required to do the attendance check. If I'm asking the question, do you like it? I know the answer is no, right? Nobody likes it. So however, we can make it fun. That's what we have done. So 10 years ago, when we started, I built something for attendance checking online. So at that time, that 10 years ago, so it's quite simple. I take photos in the classroom and publish them on the course homepage, then people can take it. And this is one I mentioned, and because the classroom is big, so I have to take 3 photos to cover every student. So I'm using image stitching I mentioned to stitch them as a whole. So have everybody in one image, then we can run the face detection. And yeah, don't be scared. Don't be scared. So I'm running the face detection to have everyone on that image. So they can go the online course to take it, is it him or not. So yeah, that's we have done 10 years ago. And for fun, most likely, because we never use that record for attendance checking or roll call, actually. So the point is we are introducing facial recognition, face detection in the course. And so it will be good. We're using this real example from ourselves to do that. That's the idea. So, later, because at that time, at very beginning, there's no facial recognition. And as I mentioned, facial recognition at that time is not that sophisticated like nowadays. So it's not reliable, but we're trying to figure out a way. This actually we figured out with the students in the classroom. At that time, the facial recognition technology is weak compared back to today. So is there a way we can do it better in the classroom for facial recognition? The answer is yes, we figured out a way. The idea is this is our all framework. We take photos in the classroom, we stitch them together and use face detection to find the faces. And at the same time, we use some technology to recognize on each row, each column, which row you're sitting there. So we know the location of the faces in terms of rows and columns there. And at the same time, this will help us to construct the student social network because friends always sitting together like you guys, right? So they come all sitting around. We can use that social network to help out the recognition. In case one of the recognition is not reliable, we can use the identity of his friends to help out the recognition. That's the idea. So that's worked pretty well. So anyway, we can do this interactively to construct social network to help out the recognition, and we help back to rebuild, to refresh the social networks as well. And this is the social networks in that classroom. You could see there are some subgroups there. And okay, so and and based on that, we see there is beside the facial recognition, sorry, we can use the social networks to help out, but at the same time, we could analyze the results because we have the social networks, and we check out a lot of literature about in-classroom performance. And it turns out there are some educational researchers are studying it, but they have different conclusions on that. The reason is in traditional study, like in the educational research, they are doing case study. This is the only way they can do it because they can't collect the large scale data, but the facial recognition and automatic social network construction make it possible because traditionally they are just using the sample size like 5 students or at most 10 students there. But at that time we have 400 students automatically collected. So we have done some analysis using this to analyze the student performance in a classroom. Like, there's one basic assumption is if one student is more active in the social network, his or her performance will be better than those not active that way. So is it true in the classroom? We verified that, yes, it's true. So this is one research we have done. The other one is a lot of teachers believe that students sitting in the front row will have better performance than those sitting in the back rows. So a lot of teachers believe that. And actually the educational researchers started as well. And when we checked out their papers, it turns out they have actually conflict understanding. There are 2 groups. One group believe that it's true. The other groups don't think so. And the reason we figured out later is when we have large scale data, because as I mentioned, we have 493 students there. So we could see that, like, those are data, this is distance to the teacher. This is the one closer to the teacher. And this is final grade, right? So you could see, if you look at all the points, there doesn't seem like there is a distribution there like the assumption said. But if you filter out those points, those we sometimes call them outliers, and the majority of part actually follow that pattern, meaning that the closer you're sitting to the teachers, you have a better performance. The reason is when you're sitting in front rows, we have better interaction there. Actually, like what I'm doing now, I'm actually looking at your expressions to see if the point has been taken. If it's not, I will say it again. And in that case, courses will be customized for you, those sitting in front rows. But there are some students They are self-motivated, well, ever decided, they have better performance there as well. So anyway, most of students benefited from sitting in front rows. That's the conclusion. But why the educational researchers have the different understanding on that? That is very simple. If you look at this data, because as mentioned, they can just pick 5 students from the classroom. It's real, their conclusion was dependent on which 5 they have taken from the classroom, right? If they're taken from the majority parts, they have the conclusion that, yes, this is a benefit, right? If they're taken from somewhere else, they may have different conclusions on that, right? So this is actually also a comparison between the large scale samples and small scale samples analysis as well. So, okay, this is a majority of distribution. Anyway, that's one thing we have done in the classroom, but things are changed a lot. People have different understanding there. The conclusion that time is facial recognition can be done in a classroom with the help of the social networks, and also the in-classroom social network is very helpful for pedagogic analysis, as the example showed, right? So anyway, we can, another thing is attendance check can be fun, right? This is 2011, we have 52 students there, but the next year, the number double here. So people are interested in that. So this is one example showing like the way we're running it, but we're not necessary to doing exactly the same thing. Don't be scared. So later we take more steps from there because we already have the recognition. I don't want to do the same thing every year, so I changed it a little bit. So later we have those expression analysis, and we can automatically get expressions of the students to see if they are bored about what I'm saying there. So, you know, when they're smiling, you see there is a happy showing there, right? And so, and this is one thing, and also, and later we put it on a drawing. So, because this is comparably a little bit long video, actually put it on a drawing. And so, yeah, we're showing that we're using it, put it on a drawing. And when the drawing portrays in the classroom, it recognizes a lot of stuff from the classroom. So you see here, that's, this is from the drone's camera. Its face can be detected, expression can be analysis there. Yeah. Okay. Yeah, this is what we have done later. So anyway, these are some example we have done there, but we can actually today I'm figure out this is a proposal like where we can do something here as well. So there's one in mind. That is the first person view cameras. You can see it's really popular as well. That's one group of the image of videos taken by the users, and it's getting, the popularity is increasing nowadays as well. You can see it's not using previous images, previous slides are more for the vlog, people are using it. And other stuff, there are another researchers are using it as well. And also at the time, a metaverse is very popular. And this is very useful for metaverse as well. And because with those first view classes, you can actually analyze what happened in the real world. I actually got one here. This is a HoloLens, and If you're interested, you can play with it. So I got it several months ago. Anyway, this is a very popular one, and we can actually do something here in this classroom, and actually prepared one stuff, and please give me several minutes to set it up, and I'm going to demonstrate what it is. Okay, hold on for a couple minutes. So we're going to have a better view. Is it good? Okay. Yeah. Okay, it worked, right? Okay. So, and we're going to do something like, because I know him, and let's see.
Name, Xiaoyong Wei, gender,
Okay, it's
male,
wrong.
age, unknown, note, professor teaching computer science.
It's embarrassing, right? And let me just try it again. Yeah, you can. He turned off his mask and he do it again.
Name, Zulu Zhang, gender, male, age, 20 to 25, note, teaching assistant. He owes you $10. Name, Zulu Zhang, gender, male, age, 20 to 25, note, teaching assistant. He owes you $10.
Okay. And let me try another one. This is Jim Fan, and he's actually someone I know.
Name, Jing Van Chen, gender, male, age, 20 to 25, note, PhD student. He is going to publish a top conference paper.
Okay, let me try him. Let's see.
Name, unknown, gender, male, age, 15 to 20, note, he looks like Andy Lau.
Great. Okay. Let me try you. Okay. Doesn't look good.
Name, unknown, gender, female, age, 15 to 18, note, she looks like a movie star. Name, unknown, gender, female, age, 15 to 18, note, she looks like a movie star.
Okay, so it's just trying to give you some idea what we can do here, and there's lag in there, I guess. Yeah, doesn't work that well. Yeah, it's work. Yeah. So it works nice. Sometimes it's a lagging, serious lag in there.
Name, unknown, gender, male, age, 15 to 20, note, he skipped class last week.
That's not true. I'm just joking. But anyway, so it's just a joke. Okay. So, and anyway, we can do something interesting there. And let me stop the sharing and put it back to the slides. Right. Okay, it's back to, back to slides. Anyway, I do think we can do some interesting stuff here. And as I mentioned, the first person view camera is gaining its popularity nowadays. And we can do something here, like what's shown here to recognize to do the facial recognition, of course, because we already done that a lot. And but I'm trying to propose here, beside the facial recognition, is we can do some celebrity look-alike application, because we could capture some faces in this classroom about you. And at the same time, we will mixture it with those faces from celebrities. So you can analyze the similarity between the faces your classmates to those celebrities. So that's the idea, and we can do it here. But I know that different people may have different understanding about the data use. People have that concerns. So we're going to, this is just a proposal, and we can take 1 week to think about it. And also we can discuss, and you can discuss, come to me and discuss with that your concern. But this is just some initial proposal. We're going to use the data. So first of all, we're going to start a survey on Blackboard. It's going to be announced after this lecture. And you can take that survey to let us know your concerns or your expectation or willingness to sharing the faces in the classroom. But actually, we're applying some policy that, like, the images you shared here only kept in this classroom. So at the end of semester, we're going to delete everything. It's going to be used in this classroom only. And data will be used for assignments if everybody agreed to do it. So in that case, our assignments can be conducted on those real images of us. It's make it more fun, right? Rather than working on the public data set. But at the same time, we'll mix them with the data sets, because we have a small group of people here. We don't have that much images there. And this is one, how we're going to use the images there or data there. Data will be shared only, I'm thinking about the strategy of using the data, because maybe not everybody want to share the data with everyone in this classroom. So that point has been taken. There's another way. We can share data in 2 levels, but the basic principle is the more data you share and the more data you get. So we can have a class group. It's a public group, which means you can join this group, meaning that, well, I'm willing to share data with everyone who is going to do the same thing. In this public group, we share data to each other once you're in the class level. So you don't care about share to others. And if you care about them, you can form private group, meaning that I can find several friends to have a private group. We just share your faces inside this group. So, but in that case, you have a smaller data sets, and sometimes when you're conducting experiments, some of the situation may not be considered. That's a disadvantage. But anyway, this is a proposal. Let's just discuss it, because we're going to start that maybe from week 3 or week 4. So there are a lot of time we can discuss with that to see your willingness to do that. And at the same time, you can share the data with and without masks there. So this another possibility of doing it. And that's pretty much about all the stuff on my mind. Anyway, let's discuss that later. And I'm going to put a survey on the Blackboard, and please take that survey to let us know. So as I mentioned, we can learn it by playing with the real data, with the data of ourselves. Okay. Besides, there's another question from students about the roadmap. So here's it, but it's just tentative. This is basically what we have done last year. It worked pretty well. So the first week is this general introduction about what we're going to do. and information about the course and the style we're doing it. And week 2, it's about image processing. We're going to teach how to manipulate the images and the videos there. So that's very basic stuff. I know there are a lot of computer vision courses that skip this part. They jump into the deep learning directly. In that case, their intention is training people to use the libraries to do stuff immediately. That's a good one as well. However, the way I'm thinking it is, besides we're going to feel about the application, it will be better to have a general understanding about each part related to the computer vision. Like I mentioned 10 years ago, image precision is really popular. It's actually initiates a lot of methods in deep learning. For example, the convolutional networks is initiated from some ideas of image precision. You will see very soon. Once you understand how to do it with image precision, you know what's happening in the deep learning automatically. That will be an easier way to get more in-depth understanding about the technology. So we're going to introduce image precision for 2 weeks. And later we will introduce the feature extraction, but with the traditional method, because I'm trying to show you the history, what happened. It's still very useful because a lot of people using deep learning, they use it as a black box. You can use a library, but you can't do anything on it. You don't know how to modify it for your purpose. So our experience is with the knowledge of those stuff, you're able to doing better for deep learning. You know where to modify, you know for what reason you're doing that, rather than just a black box. And also we will introduce image retrieval. Image retrieval is a way to use the features of images. So it applies to the traditional features which are manually crafted, and also for deep learning features as well. So we're going to introduce image retrieval a lot, but it's not only for retrieval purpose, because as I mentioned, it's a way of using features here, and it's a good example about using that. So we're going to introduce image retrieval, and later we are get to the image classification. This is where you will know how to do a facial recognition, because facial recognition is actually typically a classification problem. So we're going to introduce there, and later we will switch from a traditional image retrieval to deep learning stuff. So here's the week we actually start to introduce the neural networks and more about it, the deep learning stuff. And because I think you're ready for that. And then after we have understanding of deep learning, we go advanced image retrieval. And that way, we're going to manipulate the deep features rather than the traditional features, which with much higher dimension, and also include a lot of information more than the traditional features. Then we will revisit the image classification with the deep learning understanding. So that's the week 9. Then we will introduce something about the 3D representation and the reconstruction stuff, which are very popular there. Maybe we can introduce some image generations there as well, because the stable diffusion, which I just introduced, is gaining its popularity recently. It's really popular. So we're going to introduce it there. And also there are some advanced topics there in computer vision. We're going to use 3 weeks to introduce it. The state of the arts in different area and different topics in computer vision. I believe, based on understanding in previous week, you're able to digest those contents rather than just knowing its name, and rather than just using the libraries there. So yeah, this is pretty much about the roadmap and plan. And we can adjust in between to see your progress according to your progress. Course website, mainly Blackboard. So you can go Blackboard, have everything there. We're going to put announcements there, our slides there, assignments and projects there as well. And timetable, this is a classroom. We are going to stay here the whole semester and for lectures. And we have 2 tutorials. I appreciate they have put them together this time. It's not separated. So it's Monday starting at 11:30 to 13:20. So we have 2 lab sessions there where we're going to introduce, deliver the tutorials there. And starting from the week 2. What's a little bit embarrassing is our tutorial or lab session this semester is ahead of the lecture. It's kind of a not good situation. We're trying to figure out how to do it. So let you later. And for assessments, for continuous assessments, we have 2 assignments there, only 2, which take 30% of your final, contribute 30% of your final grade, and 15 of each. And we accept late submission up to 3 days with 10% deduction per day. And we have 1 project which contributes 25% to your final grade, and final examination is dominating in that grade is take 45, but it's open book. And so, yeah, and we don't tolerate to cheating and plagiarisms there. And this is quite important there. So, some students might be interested in some references there. I put some there. If you check the publication recently, people do not write course books, textbooks about computer vision that much. The reason is what I have introduced. This is under heavy development. It's not easy to do that because it's like technology is popular 2 years ago. They might disappear now. Yeah, so it's under heavy development, but there are, for some basic stuff, there are some still textbooks of them. You can check it out. But the way I'm suggesting you're using it is you can actually learn the basic stuff from the lecture and tutorials. And if in case you need something, you look for them in those textbooks. They might give you more details. But I'm sure for a lot of state-of-the-art deep learning stuff, you can't find them in those textbooks. And in case you have questions about that part, send me email. I will refer you to the right materials about it. Okay. So this is a way, this is pretty much about the introduction today. So yeah, more punctual. We still have something like 13 minutes. So we could take some questions there. Any questions? Oh yeah, we're going to use PyTorch most of the time, I guess, because I guess nowadays more popular than TensorFlow. But the basic stuff, as mentioned, is just the same. And on Colab, you're actually can use both, actually, and you don't have to configure it by yourself. Good question. Thank you. Other questions? You mean the what I proposed, right? it's not officially because it's just a proposal right now. I need to learn from survey you guys' willingness and in which level we're going to do it, because people may have concern. We understand that part, and also we need to develop policies or strategies of using the data meanwhile. So as I mentioned, from the week, maybe from week 3 or week 4, we're going to do it. But before that, let's just develop a protocol of sharing the data. Thank you. Good question as well. Any other questions? We can be mathematic intensive, but is that the way everybody wants? We can do that way as well. So, but based on our experience last year, we're trying not to put the mathematic intensive because there are just a lot of stuff in computer vision. But basically, the mathematics stuff is just, there's not too much mathematics stuff because you're not doing research. You're just learning it as a beginners. I guess it will be better to grab some basic understanding. I mean, from the mathematics perspective, there are little mathematics. We're trying to minimize that part. It sounds good for everyone. Okay, thank you. Any other questions there? Okay. Oh, good question again. So what we have done for release the description for projects is here, the week 10, roughly that time. So you to make sure you have enough time for that. Okay, thank you. Tutorial, I guess I encourage you to participate in the tutorial in person because you could have better interaction there with us. But in case you can't come, you can do it remotely, but not encourage it because according to the university policy, we're going to do it face-to-face this semester. Okay.
Is there any great boundaries for us to
Say it again.
Great boundaries.
Great boundaries.
Yes.
I can't answer that question right now. It's just based on your progress and the performance. Yeah. So, yeah. Okay. Any other questions there? Okay. Oh, group size. You mean for the projects, right? Group size up to 3. So based on our experience, it's a perfect number. So at most 3 persons in one group for the project. Okay. And any other? Any other? Okay. Okay, sounds perfect. Thank you very much. And I guess that's all for today. And we're going to see you next week very soon. Remember, our tutorial is on Monday at the time I just mentioned. So we're going to see you on Monday in the lab. Okay. Okay, thank you very much. Okay, bye.